All right, hello everybody. So once again, apologies for the delay, but I got a good one for you here today, and this is actually maybe a two-parter here, but we're going to talk about use of the monochromator. So the first part here, we're just going to be talking about kind of the basics of it, why you would use a monochromator, and kind of how to select the settings, and then how to excite the monochromator, and then we're going to have to give it some time to stabilize. So that would be part two, okay, after we do that. So anyways, monochromator basically is just a way to disperse the electrons that come out of the gun, and then we then can select a portion of them to then go on for our imaging or for our STEM probes or something like this. So it's a way to basically filter the energy of the electrons and remove part of the energy variation of the electrons that leaves the gun. Okay, so there, when the electrons, go through 200 keV, they don't all have exactly 200 keV of energy. Okay, there's a little bit of variation in those electrons. It can be on the order of around an electron volt or two, which doesn't sound like a lot, but depending on what your application is, that may be important, right? So, and particularly if you're doing something where you need a lot of you need to see fine details in, say, an EEL spectrum, that could potentially kill that. So that's what you use a monochromator for, is to reduce that spread down from, say, 1 electron volt to, say, maybe 0.1 electron volts. Okay, so basically like a factor of 10, and that's a pretty substantial difference. That will definitely help you see more detail in, say, an energy loss spectrum, for instance. Okay, those of you who are familiar with a performing energy filtered TEM, it's very similar to that, right? It's very similar to how you have a slit that selects an energy range, and then that goes and contributes to your image. This is basically the same thing, except it's done at the gun. Okay, so we have a series of slits and apertures. Okay, so if we look here in the apertures panel, this is what condenser 1 is if you have a monochromator. Okay, so this is your energy selecting slit or aperture, if you will. So the 2000 is basically, that's huge, right? So we're not really selecting anything here. I mean, we're not filtering right now anyway, but if we were, this wouldn't be doing anything for us. But you can see here, this is what we have. Okay, so the S here, these correspond to slits. This is 2 microns, 1 micron, half a micron, and then you have the H, I believe, are holes, right? So again, these are circular apertures. And then I believe these W, they correspond to wedge shaped. So there's a lot of flexibility here with how you set this up, okay? And so, when we're not filtering the electrons, we always leave this just at the 2000, right? Because, there's no point, okay? These come in when we actually want to use the filtering, okay? So we're going to have a little adventure here. I have done this before successfully, but we might stumble and bumble through this a little bit here. So, I mean, but just to give you an idea right now, so if I go, okay, I've got a lacy carbon film here. If I go to my monochromator tune panel here, okay, so if I bring my monochromator to focus like this, okay, what you see is I have a point, basically, okay, is I have a nice well-defined crossover here, okay, and technically speaking, this should be close to 0 at crossover. It's off a little bit, but we don't need to worry about that, okay. But this is what it looks like when we're not filtered, okay. So you can see here, right, this is on unfiltered, okay. So when we filter this, what happens is we take this spot and we and we elongate it. Okay, we end up elongating it along one direction, which is the dispersive direction, and then in the middle, that corresponds to no energy lost, and then as we move away from the middle, that corresponds to energy lost. Okay, so what we're going to end up getting once we turn on the monochromator and we tune it up and we focus it is we're going to get this spot to basically spread out into like a line almost. That will, now it's not an infinitely long line, so it's, you know, its intensity peaks in the middle, right, and then it diffuses out as you move away. Okay, but that's ultimately what we're going to get. So right now, because we're not filtered, we're not seeing that. Okay, so actually, if we wanted to properly adjust this, okay, what we could do here, we have to turn off, find the beam tab, we have to turn the C3 lens off here. Okay, and then what we have to do is we have to put in a slit, doesn't matter which one, and then we have to wobble the slit. Okay, so if we go back to right here, slit wobble. Okay, so now I'm going to use my C2 lens here to focus the slit. Okay, so we'll see what this looks like here, right? So right about there. Okay, now ignore what's happening on the sides, right? We just care about here in the middle, okay? But that's it, right? The slit is focused, okay? So then I can push this right here, and so now when I adjust C3, or I adjust the intensity knob, my C2 stays fixed, okay? And then I can take this out, turn off slit wobbler, okay? And now when I focus, right, you can see, okay, when I'm at focus here, when this is at crossover, this should be close to 0. Okay, so this is pretty close. I could probably tune this a little. So right here, right, I could push store and that sets it to 0. Okay, that's how you find the proper focal plane though, is you have to focus on the slit with C2, with C3 off, and then you have to focus to crossover, and then you can hit store. Okay, but anyways, what we're here to do is to now excite the monochromator. Let me push eccentric focus here because that was off just a little bit here. So now, if you have OptiMono, this is really easy to do with OptiMono. And we do on this system. So I'm going to go ahead and make use of this. So we have Sherpa right here, and we can go to OptiMono right here. Okay, and so what we can do is it has presets for setting this up. Okay, so we can click presets, and then if we go back here, did it do anything? Let me take a look. Where is it? Whoops. What's going on? Let's see. OptiMono getting readout. Okay, let me try. Stop. Okay, do I have to acquire FlukeCam? Okay, let's see if we do now. If we do presets. Okay, yeah, so it did adjust it. Okay, so it did. Okay, so it turned off C3. C3 was already off. Let me show you this though. If I go back to, let's say I have, okay, so this was where I was at before. Okay, I had spot size 5 on, the C3 on, and spot size 4 and C3 on. So if I come back here and I click presets, okay, that puts this to C3 off and spot size 1, and it reduces the mag down here. Okay, all right, so we can go ahead and unpause here. Okay, and there's my beam. So this makes it easy now to work with here. Okay, so we have to do the same thing that we just did, where we can do this again just to show the example. We put a slit in. I'm going to spread this out a little bit here. Okay, we wobble the slit. Okay, we minimize the slit movement with C2 like that. Then we push this to make sure we don't adjust C2 anymore. And then we turn off the wobbler and we put this back. Okay, and then we can use this to get to focus and to shift this over. All right, and then we can mag back down here to, where were we at? 2550. Okay. Okay. So we've already done these, right? We focused at slit. You could do this, and I think this will work manually, but now what we're going to do is we're going to set the excitation. So the excitation determines how much dispersion you get. So this has units of radians, and you usually do this in like increments of quarter pi, okay? So if we do, the higher we make this excitation, the more dispersion we get, and the higher energy resolution we can get as a result of that. The trade-off is, as we increase the excitation, we're going to get less current, okay? So there's always a trade-off, right? This is the trade-off with doing this, okay? So we can make the excitation really high, get really good energy resolution, but at the expense of reduced current, okay? So I'm going to set this to quarter pi for what I need to do, which is some monochromated STEM-EELS mapping, okay? So all I have to do is set this to 0.8, okay? And then click set excitation. And now what's going to happen is it's going to ramp. If we go back here, okay? So you can see now in this panel, right, it switched this to filtered, and now it's ramping this up. And as the excitation increases, what's happening, as you can see, is the beam is shifting. So it's automatically shifting the beam back as the excitation is increasing, okay? And so this is automated, right, as it's doing this. So this is one of the nice things about having OptiMono. Otherwise, we could do this just through this monochromator panel right here. You just click filtered, and then you input your excitation. Okay, but hopefully you can see what's happening here is the beam is starting to now spread along the vertical direction, which is the dispersive direction, okay? So whereas before we had a nice round spot, we're ending up with this nice elongated beam instead, okay? Which is exactly what we want. Okay, I think on here, yeah, it's not showing anything. The spot size that you use for this is also irrelevant. That's the preconditions it had with spot 1, but you don't have to do this at spot size 1. You could do this at another spot size. It doesn't matter. And as long as you're properly focused with C2, then there's no issue, right? You can see the spreading of the beam now really very distinctly. Okay, we're almost there. And there we are. Okay, so now we can see as I adjust the monochromator focus. So now we can see what's happening here. Okay, so you can see in the middle here, I have this kind of circular. It's not quite circular, but it looks circular, right? And you can see as I move away from that, it gets diffuse, right? So right here in the middle, this is where I have my zero loss electrons, and as I move away, I have my electrons that have experienced some energy loss. Okay, so now from here, we can work on actually tuning the monochromator. Okay, so we have to stigmate it, which is a little tricky to do. And again, we have OptiMono to kind of help us along the way here. What also is going to happen here as a result of exciting the mono is there's going to be considerable amount of drift in the in the monochromator. So it's good after you excite this to just, give it, some time to just stabilize. Otherwise, you're going to be chasing the beam around as you, use it later for your imaging. So I'm doing this at the end of the day here on Thursday, and then Friday I'm going to come in and start doing it. So I'll have overnight basically to give this to stabilize. Okay. All right. So good morning again. So we're going to pick up here where we left off. So what we did earlier was we excited the monochromator. Okay, so right, we put this to filtered, and then we put the excitation to 0.8 radians. We did this actually using OptiMono here. So we started here with the set excitation at 0.8, and it went through and ramped this up and recentered the beam as it did it. We also went through setting the presets for doing the tuning, which is basically simply putting the spot size at 1, turning off the C3 lens, and backing the mag out to the lowest possible setting. Okay, that's all that means. The focusing at the slit, though, you go over this again really quickly here. As you can see, the beam had shifted from yesterday, which was fine. I knew it was going to do this. Let me spread the beam out here. Okay, so we can see the support film. We can see the particles. So the way this works is pretty simple. That's my blocked by stage. What's going on here? We don't need this for what we want to do. I'm just concerned as to why that's there. So, all right, we'll leave that alone for the time being. But anyways, okay, we're going to go back to apertures, and we'll put in one of the slits. Okay, and then we will slit wobble. I'm going to mag in just a little bit to make this easier to see. And now we're going to turn off the focus here. And now I'm adjusting C2. And so we want to adjust this until the slit is stationary. Okay, that's what's going on here. That's why objective was doing that. So the stage is still moving. Oh, why are you being a pain here? Seeing if I can just knock it loose here for a minute. Anyways, that's the focusing, right? So then once we have it focused, push this focus. So now I'm adjusting the mono and not C2. And then we can take this guy out. Okay, yeah, you can see the film is drifting up. So there's something going on with the stage here. I don't know why this is happening, but the stage is drifting on me here. See if this thing is going to be a pain in the butt here or not. Okay, so now it's loose. Now it's not. Okay, we'll see if this, All right, we'll have to just deal with this here, but this was causing drift in the stage. So is it still gonna do this? I mean, we're gonna have to move around, obviously. Okay, maybe it's okay for now. Okay. All right. Anyways, let me back down to 2550. And let's turn off the slit wobbler. Okay. And then we can focus this back down. Okay. So right about there. Okay. And that's pretty close. And then we can, again, store this. Okay. So if we go back to the to Sherpa here and OptiMono. So basically what we need to do now is work through the tuning here. Okay. So now some of these we can't do because we don't have the GIF talking to Sherpa. So like this tune GIF X and Y, we can't do these. These two we can do, and then tune the stigmators we can, I believe we can do, but then I believe one of these we can't do. So actually, let me take a look here really quick. I know I took a screen snip on my phone here really quick. Okay, yeah. So we can do basically, if we did tune all, it would run all of these, but basically we can, again, because we don't have the GIF talking with Sherpa, but we can do this one, and this one, and then this one. Okay, so we can't do the mono stig X and this one and this one because they rely on using the GIF. Okay. So if we do the deflections one, okay, so what this is doing is it's calibrating the deflections caused by different elements of the monochromator, and it's attempting, okay, to keep the beam centered as it's doing this. Okay, so that's what it's doing right now. Again, when you're doing this, you want to be over ideally vacuum or something that's very weakly scattering, like there's no particles around here while this is happening. Okay, so I think what it did the shifts, mono shift X and mono shift Y, and now it's doing the mono stig X. And now it's doing mono stig Y. And a lot of this is for convenience, so that when you're tuning the mono here, you are keeping the beam centered. Technically speaking, you don't need to do all this in order to use the mono, but having this capability really helps to kind of simplify this. Okay, so we're all set here. So we can go to the next one, which is the focus. Okay, so what this is doing is it's determining the optimal monochromator focus for different values of monostigmator X. Okay, so this is done, and then we can do the next one. So this provides like a base tuning for the monochromator stigmators, and then we'll do some fine tuning after that. So tuning the monochromator stigmators is tricky because it's not like how we would normally, stigmate, right? Which we would try and get the beam nice and circular. What we're doing here with this is not trying to get a circular beam, right? Because we're dispersing the beam because we have the monochromator excited, so we're not trying to get a circular beam. So it's a little more abstract to kind of explain this. There's actually some diagrams here that I can pull up from the manual that kind of highlight how this is supposed to look. So I can show these to you when this is done. See if I can find this while it's doing its thing here. Where are we? Manuals, monochromator manual. So the manual for this thing is great. Okay, so here's the pictures. So this is when it's properly stigmated, this is what we're looking at. Now, unfortunately, this is rotated 90 degrees relative to ours, okay? But basically, if you subdivide this into like, if you discretize it to something like this, right? If you blow up these, you should get circles, basically, right? More or less. So you can think of this as like a superposition of individual spots. As I defocus them, if I'm properly stigmated, I should get circles, right? Or something roughly circular. So you can see as I'm going over and under focus, I get something like this, okay? So this is, again, if the stigmation is done properly. If I don't have proper stigmation, I end up with something like this, though, okay? So at focus, right, I don't have a nice sharp line, okay? But then when I go over and under, I end up with, instead of circles, right, I end up with slanted lines. Again, if I was discretizing this into, a series of points, okay? And again, this is if we have 45 degrees relative to the dispersive direction. So the dispersive direction, again, is this direction, which is, again, 90 degrees relative to what we're seeing on the screen. Okay, this is what happens when you have the astigmatism in the direction of the dispersion, so from left to right. But again, you see the same thing, right? So instead of in focus, you have straight line. You instead have this blurred out into bigger circles. And then if you're over and under focus, you go from focused line to like a box, okay? So it's a little more abstract to describe, correcting astigmatism for the monochromator. Let's see where we're at here. Looks like we're done. Okay, so if we go back and take a look at the beam here, let's unpause this and take a look. Okay, all right. All right, so the last thing, so now there's the focus here. So we can see, now there's one more tuning we can do here, okay? So we're gonna go back to Sherpa. And now again, because the GIF is not talking to this, okay? If we were using the GIF would actually be measuring the energy spread itself. But what we're gonna do instead is just have it correct this based on the shape on the flute cam. So what we can't use this one, okay, but we can do this one here because it's just using the flute cam. So we'll go ahead and do this one. So when this is done, we can go back and if we need to fine tune the X stig, we can do that. Okay, so this is done. Right, so if we go back and forth with the focus here. Okay, so now if we want to stigmate, so now what we can see here, right, is that we're probably still a little bit off with the stig, right? So basically, if I had this properly stigged, I should be seeing basically the same shape as I go from over to under focus. You can see this is stretched like this, and then it becomes stretched like this, okay? So we're still a little bit off here. So again, we can tune stigmator. Now my X, this is mono stig X, okay? So we're trying to get like this, trying to get this shape in the middle to be like a circle, right? So this is where it was. It was an elliptical, okay? So we can adjust this till it's roughly a circle. Okay, so that's better than how it was. That looks pretty good right there. Yeah, I think that's probably about as good as we could expect with this. And we can play around with the Y just a little bit here. We don't want to throw it off too much because we already, did it, but it's pretty obvious here with the Y, right? You can see it gets slanted that way. So the Y was already pretty good to begin with. Okay, so we're good. All right, so we'll turn off the stigmator and then I'm gonna change this to temperature because we can see this a little bit better. And why are we seeing heat, temperature? Is this because I'm seeing stuff underneath it? I don't know if that's because I'm seeing the support film. Let's see. Okay, but basically we need to fine tune this here. Okay, so it's going to be right about in here. Push store, and that's our focus point. Let me see if I do that. Yeah, so now it's a little more obvious here. So you can see now with temperature, right? So this is right here in the middle. Okay, this is where we have our optimal or our zero loss electrons, if you will. Okay, will be right in here. Let me make sure okay, we're not moving around, which is good. Again, if we want to shift the beam around here, we want to use the mono shift, right? And not something else. Do I want to try and mess with this just a little bit more? I mean, I think it looks pretty good here. Back here. Let's make a difference in HDR. No. What about linear? Okay, that makes it a little bit better. Let me switch this back here. It looks pretty good here. I mean, it's never going to be perfectly symmetric on either side of crossover. I mean, we can go back and do this one again if we want. I mean, it did a course adjustment for both of these. So if we want to do this again, we can. Let's see here. Are we back here? Oh, come back. Let's run these again, just for the sake of doing it. Tune the stigmators. You can try running both of these. I'm pretty sure this one won't work, but at least according to the manual, but we can give it a try. I know these two definitely won't. So the end goal of this, of course, is I want to collect some EELS spectra with the filtering, okay, and show you the difference between the filtered and unfiltered version. So I collected beforehand unfiltered spectra from the same particles. Okay, so we're going to see the difference, right? Hopefully, see the improved energy resolution. All right, so we're almost done. Okay, so let's go ahead and see if this will work. Okay, yeah, so it wouldn't do this. No camera selected. Let's see. Will it let us do this? Probably not. Okay, so we're stuck with doing this. So yeah, again, it wouldn't let us do that because we'd stop talking to it. And the way it's doing this monostig X is again, it uses the GIF. It actually measures the energy spread of the zero loss peak, and that's how it's tuning this. So it's not the same as what it's doing here, right? This is actually just looking at the image and tuning it that way. All right, so we're all set here. Okay, so yeah, that actually looks better than how it was. All right, so if we mag in a couple clicks here, okay, go to focus. Okay, but we definitely have some X stig here. You can see this is stretched this way and then it gets elongated this way. So let me do stigmator here. There's a little bit of Y. Okay, so that's not too bad right there. Okay, so yeah, that's definitely a little better than where it was. And it's not going to look perfectly identical on either side of crossover, but it looks basically the same here. So we're good. All right, so again, let's focus this, and then we're going to store the focal position here so we know where we're going back to. We can go back to the temperature one if we want. All right, so we'll leave it right there. Store, basically still at 0. Okay, we will be defocusing this though when we do the next thing, which is head into STEM mode and then tune up the STEM image. Okay. Okay. So in fact, what we can do now then is, well, here, I'm going to spread this out here because I want to find some particles. Particles. Yeah, we're over here. So we're not too far away. Okay, right about there. All right, I'm going to leave this spread out for now. And we will now go into STEM mode. Okay, so now we have to go back to beam tune, and because we had C3 off, we need to switch this to probe. Okay. And now, because a couple things here. So what happens now, see, let me show you this here so you can see. Is it actually monochromator less than this? Okay, so basically, if we want to make use of the monochromator, we have to use these spot numbers here. So if I go to 12, what happens here? So let me show you this here so you can see here. So this is, let me go back here so I'm not, okay, so the filtering, of course, didn't turn off. So right now I have the system in like normal condenser mode. If I want to go into monochromator spot mode though, okay, so let's say I go to spot 12 here, okay? So if I go back to the manual here, I can show you this. And I think I might have overshot no, I didn't overshoot it. Okay, so what happens here, it's a little bit different. Okay, I was not there yet. Where is it? Monochromator spot size. No? Where are you? Okay, so this is the normal configuration here. So where is the... okay. So this is what happens when we're using monochromator spot size. So what happens is we don't have the slit in right now, but the C1 lens gets set to basically spot size 11 value. So it's basically maxed out. And then we use C2 to act as the spot size control. Okay, so this is then controlling the demagnification of the image of the C1 lens right here. Okay, so this would be spot 13, this would be spot 16, right? Because the C2 lens is stronger here than it is here. So then the C3 lens, or aperture, I should say, this is what is controlling the probe forming aperture, okay, or the semi-angled collection. So now we're basically into like a two condenser system, kind of analogous to like a regular Techni or Talos, which means we no longer have the ability to dial in a convergence angle. So we lose a little bit of flexibility with the optics, but we'll still be okay. We'll have an aperture that we can work with here, okay? Again, so as I go from from a lower number to a higher number, I'm getting a higher demagnification, smaller probe, but I'm getting less current, okay? So, right, that's the trade-off, okay? So you can see now here, right, when I went to 11, okay, it went to spot size 11 and monochromator spot size 12, okay? So let me show you this again. If I'm at 11, right, it's just showing spot size 11, okay? Or if I have this at, say, 8, okay? But if I put this at 12, then spot size goes to 11, right? That's the C1 lens. And then I have monochromator spot size 12, okay? All right, so now we have to start by centering the C3 lens, okay? And so this is, if we look here, okay, so we have a high camera length, doesn't really matter here. We can go ahead, let me spread the beam out a little bit more, or the mono out a little bit more. All right, so let me turn off, actually no, let me go to the apertures panel. Okay, so I've got it doesn't matter which C2 aperture, it literally doesn't. Yeah, I mean, we can leave this on the 150 just to make this simple. Okay, so now with this, the one that we're gonna wanna use here should be the 30. This should give us a convergence angle that's around 20. Yeah, so it's a little bit higher than it was previously. If we look at, and again, I don't know if this is accurate. We'd have to actually measure it to find out. But this was the one that I remember using before, which is right in the sweet spot of the, if we pull up this guy, right, that's right in the sweet spot of our tableau. Okay, so that will work fine. Okay, so I'm going to turn diffraction off. Okay, and there is our beam. Okay, so once again, we're going to use S-core here to center, or to work with this, I should say. Okay, so now what we have to do is center C3. Now I don't think there is, if we do center C2, is it going to wobble? It's a good question if we do this. It doesn't say which one it's wobbling, so it's not going to help here. We can click done here. I mean, if we have this now set intensity and objective, yeah. So what we have to be careful with here is, I mean, so this is optimal in terms of the focus condition. Let me take just a snapshot of this so I have it to remind me what my C3 lens needs to go back to. Okay, but now if I adjust intensity, yeah, so I'm changing the C3 lens. Okay, so anyways, this is how we adjust the, this is how we center. Okay, this is just like how we would normally center. All right, so let's go back to, oh, not Sherpa, sorry. And get this more or less centered on the blue screen. All right, so we can see that's clearly not centered. Okay, it looks better. Okay, we'll do one more iteration, but it looks like we're closing in on it here. Put this down a little. Okay, that looks pretty good here. See if I can get this just a smidge better. Come on. Okay, that looks pretty good to me. So we are good with the C3 aperture, okay? So the C3 aperture position is important because this basically defines our centering position for not only the aperture, but also the the beam at focus, right, at monochromator focus, as well as the slit, okay? So let me make sure here, I put this back to where it was. So this was 47.408. Okay, and then to make sure that I don't cause a problem, right? So now my intensity knob doesn't do anything, okay? All right, let me mag in here, a couple clicks, turn this off, and now we can adjust beam tilt. Okay, and we are good to go here. So we'll go back to diffraction on. So we'll be seeing the Ronchigram. I'm going to put the mag at 640 kx. The reason for that is the highest, that's where the highest mag range starts. Okay, so now turn on your screen markings. Let me bump this up one more click. Okay, but now this is critical here because this is defining, right? Because we're going to be changing the apertures here, okay? But this will define our center position now, okay? Because we're going to have to put in the bigger aperture here to do the tuning, just like we would with unfiltered stem, okay? Okay, so now we're going to move over some material. I should say over some support film. Okay, and now we're going to focus with Z. Okay, and so now again, it's just like before, we're going to correct we're going to correct B2 and A1. Okay, so it looks like pretty obviously here we've got quite a bit of B2, right? So if you go back and forth here, bump this down here. Right, so we can see pretty obviously there. Okay, I'm getting warmer. So yeah, this is going to look a little funkier than normal here. So there's A1. Worse. Right about there. Let's do B2 again. Okay, that's not too bad. So now again, with the spot size I have here, monochromator spot size 12, I'm not going to get the smallest probe here, okay? I'm definitely, I'm trying to, get a lot of current with this. So understand that, of course. But that looks reasonable for what we want to do here. I mean, if we turn this off here. Might also want to go back and check the beam tilt again. So let's go ahead here. Apertures. Whoops, that one doesn't matter. That one out of the way, sorry. All right, let's put this back to the 30. Okay. turn this off. Okay, so it looks like we're still pretty good. All right, let's turn diffraction back on. Let's turn this on here. And just looking at this looks pretty good, all things considered. We can do some auto tuning as well. If we wanted to do it in Sherpa. Let me come back here. Yeah, so it's still, yep, still basically okay. All right, so now what we have to do is we have to focus the monochromator, and then we have to put in a slit, okay? And so these all have to be centered relative to my aperture position here, okay? So I'm actually gonna, let me pull this one out again. Okay, and let me move this out of the way here. Okay, so if I come back to beg mono and put this at and what you're trying to get is this 0 point here, okay, that you had before. Okay, now you're not trying to actually focus it on the screen here, okay? You're not trying to get this, right? This is not what you want. Okay, you want this at the 0 point that we established previously, okay? All right, so then we can shift. So we can see what's going on here. If we turn this into thermal mode, right? So we can see pretty clearly where we find that kind of sweet spot. Right, something about like that. And again, the other way you can do this is you can just maximize the screen current, right? That's usually also good. I mean, you can see, right, as I move away, I'm getting less current. Okay, so when I have my current maximized, that usually is going to be where I have it centered, right about there. Okay. All right, so now the other thing now is I need to put the slit in, okay? So if I come back here to apertures, okay, and the one I used previously was the 0.5, so I'll go ahead and put the 0.5 in here. Okay, and basically what we're trying to do again is the same thing. We're trying to maximize the current, okay? It's already pretty close here though. Just looking at it, I can kind of tell. As you can see, it went down here a little bit. Yeah, so I think the one I'm adjusting the X though is moving it like this, so it's not moving it. Yeah, so the Y is, yeah, that's the one that really matters, is the Y movement. So you can see, yeah, I mean, this was, you can kind of see the outline of it right here, right? So now actually the other thing I can do too, although I don't want to do this right now because I don't have my, well, here, let me put my C3 because I want to make sure I keep my aperture positioned correctly. Yeah, and this is about what I was expecting, about 200 picoamps. So I'm doing everything correct here. Come on. Okay, let me bump the camera length down just a little bit here. So it's going to make this maybe a little bit easier to see. Correct alignments, where are you? Okay, so again, we have this centered, right? So that's important. So basically, let me actually blank the beam here so I can show you. There's another good diagram here in the monochromator manual, if I can find it, which shows this, what we're trying to get here, if I can find it. I probably went past it again. Yeah, I did. All right, well, let me, no, did I? No, I didn't go past it. Let me go back here. Where is it? There's a diagram that shows the centering of all three of the elements, if you will. The aperture, no, the beam, the slit, and the C3 aperture. So let's see if we can't find this here. Page down. This is close right here, but this is not. Ah, here it is. Perfect. Okay. Yeah, this is right. So this this is the C3 aperture right here. Let me zoom in. Okay, this is the C3 aperture right here. Okay, this is your dispersed beam, right? That we focused, and this is the dispersive direction. And then this is this is the slit, which in this case is a slightly wedge shaped. Okay, so this is what you're trying to get, is this right here. Okay, which is what we have. So everything is right. So we start by centering C3, which we did, and then we're centering the monochromated beam, sorry, the dispersed beam with respect to it, and then we're centering the slit. Okay, so that's what we've done here. All right, so I come back here. Let me take out, now that I have that centered, let me take this guy out. See, it's a little easier to see the slit now. Yeah, so you can see basically the outline of the slit, if you will. And it's not in focus, which is, it shouldn't be, right? Because you're not looking at the right plane. Yeah, so this one shouldn't matter here. The aperture X. I'm getting a little bit more current here. That way, so. Okay, that's a little bit better. Right, so we'll de-adjust that, and we will, whoops, sorry, just habit of using C2, right? We'll put this back to this guy. Yep, and we should, yeah, it's about what we should be getting, is something about there. Center this a little bit better. Okay, and there we go. Okay, so what we can do now is we can do some STEM imaging here. You can go ahead and switch to, oh, I'm gonna have to close this and start again because of the dual screen thing. All right. So let's find us some particles. All right, and again, just like in normal STEM, we want to be doing our course focusing with Z here. Yep, so right about like that. So we can see those particles really good. I'm looking for an area where that could probably work. I want to see if there's a better spot though. We want something that's suspended over vacuum for doing the eels. I mean, there's plenty of good spots in here. Like this stuff's way too thick, but like that could probably work right there. Again, all I want to do is collect a reference spectra. I'm not going to do any kind of mapping here. Although I could do this actually. Okay, piezo stage approaching edge of range. Set. Okay, looks good. So this work that I'm doing, this isn't like atomic resolution. It's not what I'm trying to do. So, this doesn't have to be extremely high detail here with what I'm doing. So, okay, but we have this. Oops, let me center the beam. Okay, and let me pause and let me blank for the time being. Okay, so now what we're going to do is we're going to get this onto the GIF and start and collect some spectra here. So what we have to do is we have to put the GIF into what's called FTEM mode. Actually, let me bump this up a couple clicks here because I know that I'm going to use a different setting for this. Okay, and then we push. You have to find the filter panel and then push FTEM. So this changes the projection system of the microscope. That's what's going on here. So you can see now my ronchogram is really, really small. Okay, and then what I'm going to do now, go back here. Oops, actually, I don't have to do that. I can just blank the beam. Let me see here. Where are you? Beam blank. Okay. So what I'm going to do now is I'm going to change the screen input so you can see the GIF screen. Okay, so give me just a second here. All right, so we're seeing the GIF screen. All right, now one of the things that I've noticed that happens with this is that when you switch into FSTEM mode is that there tends to be a little bit of shift with the monochromator. So really quickly here, I'm going to go, you're not seeing this actually. Well, I should show you this, but I'm going to go back and adjust the monochromator shifts to make sure I get that same amount of current I was getting, okay? And we should be able to get, over a little over 200 picoamps. So, all right, so I adjusted it, so we're good to go. Okay, so we're going to start by going into FTEM mode here because we have to center the ronchigram. Okay, and we're going to push start. Okay, so there's our ronchigram. So now we have to center this. So if we have stem alignment here, so I started here, and we can just go to spectroscopy. We're not going to be doing any mapping here. And then you want to find stem alignment, and then you're going to click start, which we already did start, and then click this guy that will center the ronchigram. Okay. So this is a little bit bigger than what we were getting here. Yeah, it's about 21, but that's close enough. Okay. And then we can click here to, oops, sorry. We can click here to switch apertures. So we want to use actually, I'm going to use this one. This was the one I was using before. This is the high res. There's two probe forming apertures here. Okay. All right. And so with that, we are good to go. So we can stop this. We can close this. Oops, sorry. We don't want to save this. Okay, we're going to put this into EELS mode. And I'm going to switch the scan input to GIF on the desktop. Click start. Okay, and there we go. So there's our scan. Let me go ahead here. We'll do auto gain. Okay, here's the park position. If this is not already on here, you just right click and then click this first guy, and then it parks the beam. Come back over here and click view to start the scan again. So I want this in the middle here. One other thing I forgot, I'll go back and show you this later. You want to make sure you have Descan activated when you're doing this. That will make sure that you don't see shifting. Well, actually here, I can actually show you this here. So if I, let's start by, let's put this in single mode for now. 0, 0. Okay, we'll freeze the beam for now. And we'll click view. Okay, so if I right click on this, I can choose my dispersion. This is the one I want to use because this is what I used before. This is the shortest exposure time you can have. We're going to bump this up a few clicks here. Okay, and then we can click ZLP lock to keep it centered. And then we can do autofocus here. So when I measured the ZLP width before, okay, this is good, yeah. So the actual energy window is going to be less than this. The reason it's like my dispersion is only 0.15. So I know my actual energy resolution is less than this, but we'll see this anyway when we switch this. So I'm going to go ahead and let me bump this up again. Okay, and then let me switch this to dual. I want the titanium L edge here. And then view. All right, so let me start the scan again. Okay, so now if you watch the ZLP here. So what you see here is the ZLP kind of moves around here as it scans over a wide area. This is because I don't have Descan on. If I turn on Descan, then I don't see that anymore, right? Peak just stays where it stays, at least a little bit better. Let me put this on here. So it's, yeah, so then it doesn't happen there. Yeah, so that's with the Descan off. That's with the Descan on. So that's what we want. All right, so let me mag in here. Just fine tune the focus here. Okay. I put this over here. I'm going to turn on the focusing box. And if I push up arrow, that's going to increase my dwell time. Okay, and then I'm over here, I'm going to increase my exposure time for my height loss till I start to see my titanium. Yeah, so we can start to see it coming in there. It's my titanium core loss edge. Yep, there we go. Right about there. Okay, so I'm just going to collect a spectrum from this area. Okay, I can boost this up here. I can go quite a bit here because we want to get lots of good signal. Okay, and we'll go ahead and click capture. And the final spectrum will look much better than this because it's going to do a dark correction, which it hasn't done yet. I should say an HQ dark correction. There we go. All right, let me go ahead and stop this, and I can blank the beam right there. Okay, so here is the spectrum that I just collected. Okay, so if we now compare, so this is the, push 5 there to recenter it. Okay, so now what I can do then is I can deconvolute this. So if I come over here to EELS analysis, I push deconvolve. I want to make the background window up here. Okay, and now I'm removing the effects of pleural scattering, right? That's the this purplish one. So if I click this guy and I click Control C and then Control Alt V, then I just get the deconvolved spectrum right here. Okay. The other thing I want to do here is I wanted to extract a reference spectrum here because this is anatase titania. So what I can do then is I can go right here for elemental quantification, right click and add titanium L. Click this little arrow and click measure standard. So it already puts a window in here. Remove pleural scattering is enabled. You can click OK. And what we want to do here is use, yes, CM low loss spectrum. Okay, so then we have to specify the range. So now this is the oxygen K edge right here. We don't want that in there. So basically what I'm going to do, I'm going to call this anatase, whoops, TiO2, whoops. And then there's some notes here for, I'm going to go back and add, oh, I put a whole bunch of crap in there. How did that happen? Here, let me just, I don't know what happened here. Let me just do another one here. All right, measure, there we go. There's your low loss spectrum. Okay, so the standard name here, TiO2 anatase. Okay, I'll put the notes back in here. Basically, I want to specify, right, everything was filtered, so on and so forth. I'm going to make the range 450 to 520 because we don't want the, whoops. Okay, because we don't want the oxygen edge in there. Okay, so this is what we have here. And there we go. Okay. All right, so now what I wanted to show you, that's the deconvolved spectrum. So if I can show you the one I took without filtering, so this is the unfiltered version. Okay, so we can see the difference here, right, between these. So fine structure resolved a little bit better here, right? Separation in these peaks that we otherwise were not seeing here. And again, this is not the highest monochromator energy resolution. So now I know if we go back to, let me minimize this one. If we go back to this guy and we look at the low loss, sorry, and we do zero loss. So it's telling us the full width half max is point. It should be a lot less than this. Part of the reason for that, of course, is that it's using the full dispersion here. So if I switch this now, just so we can prove this, right? If I switch this to 15 MeV per channel, then that's going to be more accurate in terms of measuring the true energy resolution. All right, so let's click. We can leave it right there. Just click view. Let's switch this actually into single. All right, so we have to find, oh, we're blanked. There we go. All right, so we have to do We'll do autofocus here. Yeah, so you can see this was a lot less than, part of that was the dispersion, right? So this is the highest dispersion, meaning the smallest energy difference. Yeah, so this is about what I would have expected, about 120 MeV. Yeah, so now if we do a zero loss, yeah, so that's about what I was expecting, was to get something like that. So that's what our true energy resolution is. It's not what we were measuring in the other one because the dispersion was a lot higher, right? The dispersion before was 150 MeV per channel versus 15 MeV per channel. So let me put this down here anyways, and we will collect the ZLP just so we have it. Oh, it's taking a long time. Here, let me, oh, that's fine. We got enough there. I should have probably switched that to frames, but that's fine. Okay, so that's blanked. We blank the beam here. Okay, so yeah, here's the ZLP. Yeah, so if we do that, so that's about what I would have expected, based on the, the excitation of the monochromator, based on the energy slit, all that stuff. So yeah, so about 120, 130 MeV. So yeah, if we look here again, so we can see the difference here. And again, we'd probably see more of a difference if we use like the higher dispersion, meaning the smaller difference per energy channel. But even here we can see pretty remarkably, right? We can resolve the fine structure much better here than we could otherwise, right? Without the without the monochromator on. So that was what I wanted to share here. And again, right, this is, as far as we can do much higher energy resolution than this, to be sure. This is, again, partly the dispersion used, right, which I didn't need the super high energy one, or I'm sorry, super high dispersion one to show what I needed to show anyway. So just enough to show better separation of the for the splitting here, right? So this is the L3 versus the L2 peak. So you can see the separation here much better with the filtered versus the unfiltered. So yes, let me go ahead just really quickly here. So let me show you this so I can drive this home a little bit better for you here. So the issue with the Descan, so you understand this better. Let me go ahead and do view, unblank, click view. So I start the scan. So right now the beam is scanning, okay? I have Descan on. Okay, so what's happening here, increase the dwell time here. Okay, so basically if you have your Descan aligned properly, you shouldn't see the ZLP move around here as the beam is scanned. So actually another way to do this here, I can click view and then I can actually move my beam around, right? So you see here, let me turn off ZLP lock. Oh, no, I need to do that actually. You can see this is not moving as I move my beam around, right? So it's shifting because of the just inherent stability. Let me turn on the lock here. Oh, let me turn this off here again. So you can see I'm moving the beam around to the corners and it's not really moving around. If I turn off Descan, watch what happens here. Oops. Okay, so see the difference? Okay, so that's what the difference is with the Descan. So you need the Descan aligned, which is something you do before this, and then you want to activate it when you're doing EELS. That basically makes sure that you avoid shifting of the spectrum along the energy axis. This is more of an issue with lower mag scans, right, where you're scanning a wider area. If you're doing like atomic res work, it's really not much of an issue. But this can be more of a problem again if you're doing something like wider field of view. So the ZLP lock works well for this, but it won't overcome like the Descan artifact. So that's something that you really do need to align beforehand. And let me show you where that is actually in the microscope control software. So let me go ahead and blank off the beam here, and then I'll go back into the room and show you. All right, so we're seeing the microscope interface now. So here is the D-scan right here in the STEM panel. Okay, so it's just this guy. Want to make sure it's checked. Okay, and that's basically, yep, that's a crash course in monochromated STEM-EELS. Certainly, wanted to go over how to do that. So I've been meaning to do a video showing how to use the monochromator. So as always, of course, if you have questions, feel free to let me know. Hopefully this is a nice addition to the video library here. And with that, I hope to hear from you soon and hope you have a good day. All right, thanks everyone.